Hi, good morning. My name is Paul, and I'm a product manager on Brillo and Weave. And I'm also looking after security for the products. So, looks like you can see that. So I'm going to jump right in. There's a lot to cover, and I may have time for some questions at the very end, but I'll also be at the office hours for the next 2 hours, so feel free to come by and talk to me there if you do have questions. So I'd like to start with just what is IoT security. IoT can be a pretty broad term. I'd like to give a little context for sort of for the next half hour so we can all be thinking about it in the same way. It's about all the things in the product, and this is especially important when it comes to IoT. There's usually several different parts: a cloud server, an app, mobile app or two, and then the device itself. So if we want to talk seriously about security, we have to think about each of these things and the different ways they might be attacked. And we also have to think about all of the networks that they use to communicate. The second thing that we feel is very important is that this isn't just another web service, right? These devices are in your home, your office, car. They can record data, they can control things, and if one of them is compromised, it can be used as a jumping off point to attack other things in that area. Let's take a quick example. Here my webcam is monitoring my living room. This picture of my dog ends up everywhere. So now the data could be stolen from any of these places, right? It's not just on my camera. And it isn't really just about the data. If they manage to steal the credentials, then they might be able to control my webcam remotely in the future, and I might not even know that they're doing it. So we really have to look at the whole system if we want to build secure products. So this sort of thinking led us to a few of the big elements of security in Brillo and Weave. And you may have seen these from the first day keynote, but just to reiterate, the first item is that the owner needs to be able to grant and revoke specific privileges to people, apps, and other devices. And this also means that the system itself needs a way to authenticate the owner and those other people, apps, and devices. And so we'll talk about how that works. The second thing is that any user data needs to be stored securely on the device, on the servers. It needs to be transmitted securely among these things. There's no cheating on local networks that you think are secure or back-end cloud servers that just don't encrypt the stored data. And the final thing is, oh, I had a click there, sorry. And the final thing is that the devices need to be resistant to attacks, updatable, and recoverable in the case that there's a problem. So with that in mind, let's look at a few places where real-world products have had problems in the past. I'll leave out the names, but if you're interested, there's a long reading list at the end, and you can go educate yourself more. So, home automation system that trusts the local network. This particular home automation product has an iPhone app. The iPhone app can be used to control your home remotely. So how does it do this? It gives the iPhone app an authorization token that it presents to the cloud server when you are remote. And the cloud server then presents that to your house, and you can control it. But it turns out they'll actually give any iPhone app on your local network this token. But it's okay, right? You only let your friends on your home network, and you trust your friends. But the catch that we all have to be thinking about here is that means you also have to trust any device they add to the network, and that device isn't running any malware or hasn't been compromised, right? So now you're several layers down. And so if any of those devices are compromised or are running a malicious application, that device can then request this token, get this token, send it off somewhere that can then be used to control your home remotely. So it's much better if you just don't trust other devices in the local network, and you use sort of an end-to-end authentication and encryption model with all of your communication. I'd like to complete the story a little bit because this was something that, frankly, was news to me when I started really digging into this area, into the world of how malware gets onto a laptop or a phone. We're all familiar with the basic advice: don't click on links that you get from someone you don't know, et cetera. We all do that, right? But it turns out with the right kind of exploit, a malicious or a compromised website can actually install malware on your machine just by you loading the web page. Right? And so, for example, a zero-day exploit in your browser, your Flash player, your Java runtime can actually load up on the page and plop some code on, and you might never know that's happening. There is also a whole market where people buy and sell these exploits, right? So this does happen. It's a pretty, it can be a fairly expensive exploit to implement. So not all products might consider this attack case, but the mitigating it is fairly cheap. So, and it's the same thing we just mentioned, right? If you do end-to-end authentication and encryption of devices, you don't trust your local network, you can mitigate the impact of this kind of attack also. So we should take a serious look at that. Okay, let's move on to look at smart TVs with weak secure boot schemes. For those of you who aren't familiar with secure boot, it's simply a way to make sure that the image that the device runs after it boots is authentic and hasn't been tampered with. So that if someone does insert malware into the device, when you reboot, it should detect that and say, something's wrong, please recover me. It's also a very important part of securing the auto-update process. So if I'm shipping an image in from the internet, I don't want that device to run the image unless it's authenticated to be from the original manufacturer and also untampered with. So probably your devices will implement something like this. This is something we'll come back to, but in the case of this smart TV, they did this. They implemented a secure boot model, but they used a simple encryption mechanism, and as the secret key, they used the model number of the device. So you can bet the hacker community figured that out pretty quick, and they made it easy to produce images for the TV that contain whatever you want. So if you're a weekend hacker and you want to install some software on your TV and have it do some stuff that you like, then this is actually really great for you, right? But if someone wants to take over your TV without you knowing, then this is a pretty bad thing. So one mitigating factor here is the updates were only possible via USB. That has other maintenance issues that we'll talk about later on, but in this case, it meant you couldn't compromise the devices remotely by knowing this. But what it did do is enable a drive-by attack. So somebody could walk by your TV, plug in a USB stick, get it to load the update, and then pull the USB stick and walk along. And so for something in your home, that might not be a major concern if you, again, you trust your friends, you trust your house guests. But a lot of these televisions are actually deployed in commercial or retail spaces where that kind of, a few minutes of unmonitored access might be completely plausible. So the moral of this story is really should implement a strong secure boot scheme. We'll talk more about what that looks like. Third example, this is kind of a broad example. A lot of the research that is being done on IoT devices, security audits, is showing that a lot of the servers, the web servers that people use to interact with the devices remotely are very weak on basic security things that we've known for a long time in the web server development process. And we touched on this a little earlier. This isn't just another web service, so you need to take things a little more seriously. For example, a lot of websites don't offer even basic attack mitigation. So I can try the password 100 times, and it doesn't lock me out, and it doesn't insert a delay. So brute force attacks become possible. There's no two-factor authentication for most websites. Understandably, it takes a little more work to implement, but what that means is you can be much more vulnerable to things like phishing attempts. Put in your password, and then they get your password, and then off they go. And finally, they make it very easy to simply reset your password with an email. So that by itself seems okay because your email account might be secure, but that means then any of the other mechanisms, if you're using an email account that doesn't have a good password or doesn't have a two-factor authentication, then you're vulnerable that way. So again, when this account access might allow you to unlock your door or your car or view the webcam in your house, you really have to implement best practices when it comes to securing your web server as well. The final thing I'd like to look at is a little bit different, and that's because physical security isn't always considered for consumer devices. And that's fair in a lot of cases. If you imagine an attacker who has persistent physical access to your device and they can open it and play around with it, and if they have sufficient time and budget, they'll almost certainly compromise the device. There's really, right, you could try to build an ATM machine, but it's seldom worth the cost. So that doesn't mean it's not worth considering at all. And within your specific use case, it's worth identifying what are the physical attacks and how they might be mitigated in your case. So let's look at this one. This is a hotel door lock. It had a configuration port that was accessible from the outside with just a couple of minutes of work. The attacker did have to be prepared, but it was a $40 preparation and a 30-minute process. And so then they show up at the hotel door, plug it in. Plug it in, there's no authorization required once you're plugged into the report. You can just read all the memory off the device. So that by itself maybe allows you to compromise a single lock. But on the device, the manufacturer had stored a shared secret key that was used to authorize many rooms within the same block. So it could be the whole hotel. It could have been if they separated it by wing or something. So by having this key, then the attacker could create a card that would work in any of these doors that shared the same block. So we're talking about just a few minutes physical access, and boom. What are some lessons we can learn from this? Well, you might say take away the programming port, and that might be practical in some cases, but this is always a usability trade-off with security. So it might be more appropriate to leave the device with the programming port, but implement some kind of authorization on it if you recognize that people might access it without authorization. But beyond that, the most important thing is think about what happens when your device is compromised. How widespread is the value of that compromise, right? So in this case, they really should have come up with a way to scope that shared key down a little bit, come up with another way so that if one device is compromised, you don't get access to lots of rooms. You just get access to that room. So up to now, we've talked about what elements should go into security, and we've looked at some empirical lessons from other devices. There's a lot more of those, but I didn't want to take forever on that. So let's look at how Brillo and Weave can help you make your IoT products more secure. Weave handles the user accounts and sharing for you. So it provides an integrated solution across all of the devices. It understands the concept of a user, and that user is the same user when you log in on the web, and it's the same user when you log in on the phone, and it's the same user that the device thinks it is. And that's all based on Google accounts. So right off the bat, you get this sort of state-of-the-art user authentication that's built in there, password strength indicators, repeated bad login attempt blocking, optional two-factor authentication with several different mechanisms. On top of that, we've added some IoT-specific features. So a secure way to identify a specific user on all platforms, which I mentioned. But from there, the owner can share that access and revoke that access from other users who are understood in the same way. So that provides a very consistent experience for users across many devices. And think about it like Google Docs sharing, but for your devices. So you pick the device, you share the device, you pick the privilege, share the privilege. So the next thing Weave provides is data transmission security. Like we talked about, all of this endpoint security is fairly useless if I can sniff your traffic or spoof your traffic whenever it goes over the network. So Weave secures everything end-to-end using TLS, whether it's the local network or over the internet. For those of you who are interested in the Bluetooth BLE, we'll be doing work there as well, so stay tuned. And then all the data stored in the Weave cloud is encrypted when it's on disk. So that limits the exposure in all of these different areas without any manual effort on your part. So all of that's good and it makes sense, but the big wins start to come when you can use Weave instead of implementing these things yourself. So the more you can use the Weave and Google provided services, the more you reuse the existing code that we already have and the best practices that are implemented. And for the parts that are maintained by us, that's simply less work you need to do yourself. For each of these items, it's the kind of thing where as your product, you can choose, right? You don't have to take all of them. You can take some of them. You can add your own service next to it. We're trying to strike a balance with Weave so that it provides a lot of value, but when you have a particular need to go outside of that, you can. So that way you can capture as much of this as is relevant for your product. So let's look at Brillo. Brillo provides integrated updates. We've spent a lot of time on this in some of the other talks, particularly the services talk yesterday. And so for those of you who are interested in that, I'd recommend you go and review that if you didn't see it. In a nutshell, though, devices that are secure today will have some exploit tomorrow. We can't anticipate what that will be, so we need to provide a full-service solution. Google maintains the operating system, and we make security fixes available. Developers fix, sort of got a little progress bar here. Developers fix their software, or with the new distribution of our software, they pop that up to the developer portal. The devices in the field pull it down. We secure the payloads. You sign the image, so the device will verify that image before it will run it. And then, as a second step here, crash reporting isn't always thought of as a security element, but stability and security really go hand in hand. Things that can crash your device can potentially also be used to exploit your device. So watching crashes and trying to understand where your big stability problems are, we feel is also an important part of security. I bundle it with updates because it's one way to tell if your updates are sticking. Finally, updates are applied in the background so they don't interrupt device behavior. This is fairly important because you really don't want to end up in a situation where the fix for an exploit has been available for months, but nobody's installed it, so all of your routers are vulnerable to attack, for example. So finding a way to allow the consumer to get updates that they will actually apply and that doesn't either have a lot of friction to that process or cause them a lot of worry is really, really important to getting people to actually apply these updates. Finally, and it looks like we will have time for questions. Finally, I'd like to end with a discussion on defense in depth, which is a kind of security ideology that we feel works quite well in this area. So this is a photo of the Dún Angus Castle on the Aran Islands in Ireland. And I've only been there once, and it was a long time ago, but it really stuck with me. And you could see somewhat from this picture. I looked for my own pictures, but I didn't have any. It's too long ago. So these rocks in front, when you approach from the top, you're like, what is this field of rocks? And actually, it's cavalry defense. So if you got to the island and you got up the 200-foot cliff to the castle with your horses, yeah, you'd be so tired. But then, then you have to cross this boulder field with sort of spiky rocks pointing toward you that the horses wouldn't be able to navigate. You have to climb the wall. Once you're inside, there's additional rooms, right? So for you Game of Thrones fans out there, this is more difficult to attack than King's Landing, right? I think. But the summary here is that if one defense fails, then there's others waiting to make it harder to actually capture any benefit from your successful attack on the first defense. So an attacker has to be very persistent and very successful through many layers before they can really get to their goal. We think about device security in much the same way. So verified boot, which is what we call the secure boot that we talked about. Verified boot starts from the very moment the processor powers on. It verifies all of the software that you're going to run all the way down to the root file system where the executables live. So any changes or compromises there will be caught. If something makes it past that, then there's process sandboxing and IPC, interprocess control, authentication, so that if a single process is compromised, it can't escape and gain additional privileges very easily, or it can't attack other processes very easily. We have a mandatory access control mechanisms. This was brought up, SE Linux and SecComp. I think Gaurav mentioned it in the fireside chat. The idea there is just to provide an additional defaults for anything that you might have missed. And then there's all sorts of other things like toolchain configuration for address randomization, so that some of the attacks that have emerged over the years and are well known are protected against without you having to set any configuration yourself. We build all of the Brillo core services and set up the operating system using all of these things, but just as importantly, we make the tools configured and available so that you can build your own software while continuing to take advantage of these things. So that way, the whole thing. In addition, we'll keep adding to this list as we go, right? This is an area, there's lots of little bits that fit into making an operating system as secure as possible, and as new best practices are found and implemented, or as things evolve, Brillo will be tracking that. So I'd like to summarize what we covered. Really, IoT security needs to cover the whole system. We saw a couple of examples where a mistake in one area, like trusting the local network, can allow remote access to the devices in the home. It's happening over and over. Developers are rolling their own and rediscovering all of these problems the hard way. If you read some of the security researchers that have been in the community for 20 years, they're saying, hey, these are all problems we discovered long ago with web servers and with other devices, and it's really a shame that people are rediscovering them. What we should be doing is trying to move some of that knowledge into this new program. And finally, Weave and Brillo provide the building blocks to build more securely with less effort. The one thing I'll end on here, especially on that last note, is that security is both holistic and quite specific to the product that you're trying to build. So we want to provide best practices and some checklists and some tools and software to make sure that you can build a secure system and a secure device. But we can't do it all for you, essentially. The specific attacks that your device might want to mitigate against, the environments it's going to be in, the special features that you're adding or being asked to add, all need to be looked at carefully. One of the ways in which security is most commonly broken is when you designed a system to fit into a particular environment and to do a particular thing, and then you're asked to apply it in a slightly different environment or asked to add a slightly different feature. And you either bolt it on in the end, or the marketing department sells it into that area, and then suddenly, like with smart TVs that they assumed were secure for a home, may not be secure in a retail environment. So really trying to think about all of those places your device might go and at least have a plan. So with that, I'll take a few minutes of questions. There are mics on the left and the right on the first level here, and then I think there's one up in the balcony. As other speakers have pointed out, I can't see up there very well, so feel free to holler if you're up there. Oh, reading list. I assume you guys can all see this offline somewhere, but there's a lot of good stuff here. And that's it. Oh, you want me to go back one? Yeah. Do a question over there or just someone standing? I see, okay. Okay. I'm not seeing any questions. Going once? Going twice? Okay. Thanks everyone for coming. To see you in office hours.